So, hello students. In the last session, we have seen different methods of solving equations. Okay, that is elimination, special elimination, and substitution. Here we'll look at RCM technique, and we'll also look at solving equations that are actually not in the linear form. We can convert them to suitably to linear form, and then we can solve for them simultaneous equations. Okay. So let us look at uh, a problem where we can solve using RCM technique. All right. Let's look at, yes, we have a question out here. Okay. So this is solved by RCM method. And so again, you have to go with the method that is specified. So you have 3x minus 4y is equal to 2. Okay. And y minus 2x is equal to 7. 3x minus 4y is equal to 2. Y minus 2x, I need to make it as minus 2x plus y is equal to 7. So be very careful here. You see, I have put y minus 2x. So you need to get that order right. 3x minus 2x minus 4y plus. So first x, then y, and then there's a constant. So even if it is jumbled, see that the order is correct because it is very important, especially for RCM technique. And if you recall, I also told you that you need to make the coefficient of that is not coefficient. You need to make the constant term as 0 on the right hand side, as in you need to ensure that the right hand side is 0. If there are any constants, do bring them to the left hand side. All right. So what I will do is I'll say 3x minus 4y. I'll bring the 2 this side. It becomes minus 2 is 0. Call it as equation 1. And likewise, in this case, minus 2x plus y minus 7 is 0. Call it as equation 2. Now, it might be very tempting to solve it by substitution because coefficient of y is 1, isn't it, in the second equation? We can go ahead if we were not informed to do by RCM method. Since we are instructed by RCM method, we have to go by it. Of course, you can cross-check later. But now, as we are learning the RCM technique, let's go with the RCM method. So now, what is the first step? Yeah, add them in the correct order. That is first x, then y, and then the constant. And the RHS should be 0. The right-hand side should be 0. Suitably, you have to move the coefficients or any other constants from the right-hand side to the left-hand side. Now, it's simple. You just write the coefficients neatly. I'll just change the color. Okay. All right. 3 minus 4 minus 2. 3 minus 4 minus 2. I've just written coefficient of x, coefficient of y, and then the constant term of equation 1. 2 times I've written. Same thing for the equation 2. Minus 2, 1. Coefficient of y is 1 here. When nothing is mentioned, it is 1. And then minus 7. So minus 2, 1, minus 7. Write it again. Minus 2, 1, minus 7. Then fence out the borders. Strike them out. All right. Now what will we do? We are going to, okay, I'll just change the font. Now I'm going to put x over here, y over here between the second 2 columns, and between the last 2 columns, I'll put 1. And I have to cross multiply. I have to cross multiply. So what will it be? X upon minus 4 into minus 7. What is this product? Minus 4 into minus 7 will be plus 28 minus this product. This product is minus 2. So it will be plus 28 minus minus 2 is equal to y upon, similarly, this product, that is minus 2 into minus 2 is plus 4 minus this product. This product is minus 21. So it will be plus 4 minus minus 21 is equal to 1 upon, we have 1 here, isn't it? So it will be 1 upon this product, 3 ones are 3 minus this product. Minus 4 into minus 2 is plus 8. 3 minus 8. Okay, be very careful with the sign. So it is 3 minus 8. So just let's go down. X upon 28 plus 2 is 30 is equal to y upon 4 plus 21. Minus of minus is plus. 4 plus 21 will give you 25 is equal to 1 upon negative 5. And now you have to just take these two equations together and these two. Okay, if you take x upon 30 is equal to 1 upon negative 5, so x will become 30 upon negative 5. So taking the 30 up, x is equal to 30 upon minus 5 is minus 6. Likewise here, y upon 25 is equal to 1 upon negative 5. So take it up, you get y is equal to 25 upon negative 5, which is negative 5. So you get x is negative 6 and y is negative 5. These are the answers. And you can always cross check later. If you put, let's say in the first equation, 3 5s are 3 into minus 5 minus 15 plus 24, 4 into 5, right? 4 5 are 20. We will get 3. Let's check. 3 into first equation. This for us to know whether I've gone right or gone wrong. Anyway, 3x minus 4y is 2. 3x minus 4y is 2. Just look at the right hand side. 3 into negative 6 minus 4 into minus 5 minus 18 plus 20, which is 2. And that's your right hand side. Okay. So it's satisfied. So as I told you, the method wasn't mentioned. The best method would have been in this case to go with substitution. But they have mentioned or they've instructed you to solve by RCM. So you have to go with the method. Now, going to the next method, the next technique, that is for, I told you, equations which are not in the linear form, but which can be converted into the linear form. So these are problems of this sort. Yes, let's go down. It will be 14 upon x, okay, plus 3 upon y is equal to 5 and 21 upon x plus 8 upon y is equal to negative 3. Simultaneous equations. 14 upon x plus 3. See, we should need to have x and y on top. But if I take them on top, the power of x, the exponent becomes negative 1. Likewise, the power of y becomes negative 1. No longer are they linear. So, we can make a substitution telling let 1 over x be equal to a, let 1 over y be equal to b. So this equation boils down to 14a plus 3b is equal to 5 and 21a, 21x by 21 upon x is 21a and 8 into b is equal to negative 3. This is your equation 1 and you can call this as equation 2. There you go. You have equation 1. This is your equation 1 and here you have equation 2. Okay. So with this we can solve by any suitable method. Now again, when the method has been mentioned, here they just told you to solve. Generally, when they give you problems of this sort, they will not tell you to solve by a particular method. You just have to make the proper substitution, telling 1 by x is so and so, and 1 by y is so and so, and then you can solve by any appropriate method by looking at the coefficient. Now, nothing really strikes me, but I know that in equation 1 and 2, the coefficient of a, yeah, they happen to be multiples of say 7, right? So you have, what is it? 14a, you have 14 and you have 21. So we can try to get the LCM. We can try to eliminate. Otherwise, if you want to eliminate b, the LCM of 8 and 3 will be 24. So LCM of 14 and 21, 14 3s are 42, 21 2s are 42. So the LCM of 14 and 41 happens to be 42, which I can easily get when I multiply 14 into 3 and 21 into 2. So we can go with this. So what I will do is the first equation, that is 14a plus 3b is 5. Let me multiply it with 3 because 14 3s are 42. I'll do that. Okay. So 14 into 3, 42a plus 3 into 3. I'm multiplying everything by 3 now. 3 into 3, 9b is equal to 5 into 3, 15. That is equation 1. Second equation, I want 21 into 2, which will give me 42. So the entire second equation should be multiplied with 2. Equation 1, what have I multiplied with? It is with 3. This equation I have multiplied with 3, isn't it? So equation 1 is multiplied with 3 to get 42a plus 9b is 15. Equation 2 I'll multiply with 2. So what will I get? 21 2s are 42a plus 16b is equal to negative 6. That is the equation 2. You can call them as 3 and 4 also, but you can leave them as 1 and 2 because we are going to solve them now. Okay, so now let's solve for a and b. Remember, we have to back substitute. We need to get x and y. So 42a plus 9b is 15. 42a plus 16b is negative 6. Be very careful with the negative signs. Adding, subtracting, or multiplying, dividing. Because when we tend to forget that negative into negative is positive, or negative into positive is negative, then things can go wrong. Now let's put them together. So equation 1 will be 42a plus 9b is equal to 15. Equation 2 will be 42a plus 16b is negative 6. What do I have to do? I have to subtract because I have the coefficient of a as plus 42 in both the cases. So 42 minus 42 will give me 0. I want to eliminate a. So let me do equation 1 minus equation 2. So what will I get? 42 minus 42 is 0. Plus 9 minus 16 is minus 7. Minus 7b. 15, and this will become positive. Minus of minus because signs will change, isn't it? While subtracting. 15 plus 6 is plus 21. So what will it be? B will be 21 upon minus 7, or B is negative 3. But then remember, we'll also have to find A. We'll find A and B, and then we will find X and Y. So now that we have B is negative 3, we can substitute for B in any of the equations. You can look at 14A plus 3B is 5. 14A plus 3B is equal to 5. So when I'm naming them, even after transforming, I didn't change them to 3 and 4. That's also fine. You can name them as 3 and 4, or you can name them as 1 and 2 also. But when you're multiplying or dividing, or when you're multiplying with 2 or 3 or whatever to get the required coefficients, just be careful and see that you're referring to the right equation. That's right. Otherwise, we could have also named them as equation 3 and equation 4. Okay. So come to this equation. 14a plus 3b is 5. 14a plus 3b is 5, right? This equation I'm talking about. There, I'll just substitute for b. I'll get 14a. I know b, right? 3 into minus 3 is 5. So 14a, 3 3s are minus 9 with negative. So it's 5. So 14a is equal to 5 plus 9 is 14. A is equal to 1. If I know b and a, I can now solve. Because 1 by x is a. 1. 1 by x is 1. Because 1 by x is a, right? 1 by x is a, which is equal to 1. Or 1 by x is 1 by 1. 1 by 1. That means x is equal to 1. Similarly, if you look at b is equal to negative 3. So 1 by y is b. So 1 by y is minus 3. We can say minus 3 upon 1. When you take the reciprocal, y is equal to 1 over minus 3. So you get x is equal to 1 and y is equal to minus 1 by 3. Finally, we solve for x and y. We first had to modify. We had to rewrite 1 by x as a, 1 by y as b, solve for a and b, and then back substitute. Don't forget to back substitute because we cannot solve for a and b. We have to solve for x and y. We are solving for x and y here, and that's what is needed. Okay. So I hope these two techniques have been clear to you so far. So in next session, I'll just come up with more revision content which will be suitable for which is apt for this. Okay, that is for your other trigonometry and other things. Right now, I've discussed only simultaneous equations and different types, that is simultaneous equations by RCM, by elimination, substitution, special elimination with different examples. So in the next session, we will see more of trigonometry. We'll see more of other things like exponents and factorization and all those things that we have discussed. Okay.